Good afternoon. Welcome to my presentation on performance evaluation of short algorithms in tracking of fish in a school. So let's discuss the first. What is short? The short is an abbreviated form of simple online and real-time tracking algorithm. Basically, it is online tracking algorithm based on Kalman filter, and this Kalman filter used for the state estimation, and it has several extensions, and we know that OC short is the latest. And how the OC short and the short works, basically, we can see from the figure. So we need to consider the detection and tracking for the tracking algorithms. For the short, the author used the faster region CNN for the detection purpose. And in the tracking part, they use the Kalman filter for the state estimation. And finally, they use Hungarian algorithm for the tracker association. Now let's discuss about the scenario of the fish tracking. Because we know the tracking of fish is much different from the tracking of pedestrian or other objects or car. Because in case of the fish in school, we can see very similar races, very similar appearance of the fish. And the fish frequently merges each other, that means crossing, even for the several frames or several seconds sometimes. And the trajectory and the movement pattern is very much complex sometimes. For this why it is sometimes difficult to predict. So in this scenario of the fish tracking, I would like to apply the short and the latest extension of the short, which is called OC short. I would like to apply to see how the short algorithms perform for the tracking of fish in school. Now let's discuss what is the difference between short and OC short. Technically, we know the short is basically the estimation centric based on Kalman filter, and on the other hand, OC short is observation centric. That means the object's location based on the location of the object. And the short is a constant velocity model, but OC short is a nonlinear model, and it considers the velocity direction, which is called the momentum. And OC short has also combined the recovery part, which is called the OCR. And so in simple, you can say the OC short is the updated version of the short, and it should be performed better because in case of short, there are error accumulation or magnification occur at no observations. That means when the several frames or several stems, if the object is not detected, the times the trajectory or localization error is accumulated because it is based on the estimation centric. And on the other hand, in case of OC short, such a error magnification is not occurred because once the object lost its track or detection, that means no observation. So after certain steps or frames, if it is again detected, so it's correct their trajectory based on their OCR. For this why my hypothesis is the OC short should perform better in tracking of fish in scope. For this why the objectives of this research is the performance evaluation and comparison of short and OC short for tracking of fish in school in terms of max ID. So as a performance evaluation, I use max ID. So let's clarify what is max ID. So if the number of object or fish in our case 20, if we subtract this number of object or fish from the max ID, basically it indicates the number of identity lost. So for this Y, it means the lower number of the max ID value or number of identity lost indicates the higher performance of the algorithm. Now let's move to the materials and method sections. I used juvenile IO fish, 20 fish in a school in a flat trend, 3 meter by 3 meter flat trend. And we captured the video from the top with the 30 frame per second. And as we know, for the tracking algorithm, we need to combine the detection and tracker together. So in our case, we use the YOLO V5 retained PyTorch model fine-tuned for the detection purpose. And we combine this detection to the tracker at the short and OC short. And the parameter I mentioned is here is the default setting for the IOU for the detection and tracking and the confidence level for the detector. And this is the input video. We can see the 20 fish is moving randomly. Yeah, okay, this is 5-second video. It's about 150 frames. Let's move to the next slide. So this is the result of the YOLO V5 detection. So I made the video slower to make it more visualized. And we can see the detector is quite good because the confidence is higher. And almost it detected in every cases. Okay, this is the actual result of the tracking using the OC short tracking algorithm. So let's say the 5-second video that includes 150 frames. Yeah, this movement is quite fast. Difficult to observe the identity lost here, but we can explain the latter and visualize it. So now see the difference between the performance of short and OC short at default setting. And we can see the OC short perform well because the identity lost was 11 times in case of OC short. But on the other hand, in case of short, it was 21 times. But it's still not satisfactory, both of the algorithms. We need to improve the performance for the XOR setting. So here we can see more clearly the tracking results of the short and OC short. Let's see here. The left side is short and right side is OC short. And how the identity lost is because of the most of the time identity loss occurs when the fish merges each other or cross each other. And the OC shorts, yeah, able to reassign the same ID, but in case of short, it's failed to recover at the default setting. Let's explain how this is occur. So in left side, in the short case, we had a 20 fish. That means 20 identity ID. For example, if the ID number 10 is lost at the crossing section, and again, it detect fish is detected. So in case of short, it reassign the new ID. But in case of the OC short, once the ID lost, for example, 10, once it's separated and it re-detected and retracked, and the tracker reassign the same ID. Yeah, but sometimes like 10% is failed even OC short, because if the crossing is very long time and the trajectory is very complex, like moving very fast and unpredictable direction, the times OC shorts fail. So basically the rematching algorithm or recovery part of the OC short make difference here. Let's move forward. I showed here one example, the fish number 1 and 14. Two separate fish cross each other and again separate. So let's say here the video slowly. The fish 1 and 14 is coming closer. They cross each other, lost identity 14. And this separating again. And new ID assigned for the 14, 23. But one remains 1. Okay, let's see the OC short result, the same case. The ID number 1 and 14. So 1 and 14 fish is crossing each other and identity lost and separating. So it reassigns the 14 same ID. So that is able to recover the same ID. Okay, so in roughly, if we summarize like why this kind of poor performance for the short and OC short detection and tracking, you can see two fish is, looks very similar, and the frequently crossing or merge or overlap. And this is, two reasons. Another reason is lighting conditions for the video. Probably we need more resoluted and more clear video so that the algorithm can detect the object and distinguish even the two objects. And another thing is like the movement pattern of the fish, which is sometimes very complex or unpredictable. Yeah. For this why we need to improve the performance of the short and OC short. As I told, this is not so satisfactory in default setting. So I took several initiatives based on the parameter, and I summarize here. Like for the detection, I reduced the confidence level to 0.5 and IOU 0.2. So why I need to reduce this value is because, as I told, that sometimes there's a poor predictable of the trajectory of the fish. So if we reduce the value, that means the high possibility to. So that means it increased the possibility of the accurate detection and tracking as well. And another thing is, as I told, they frequently merge and they remains for several frames, even sometimes 1 second. So we need to increase the maxes. That means the maxes, it means it should not be, the tracker should not be deleted. It should be remain, and it can assign once the two fish is separated. The another approach is using ZIOU instead of IOU. So it is called the generalized intersection over union. In the left diagram, we can see how it is calculated. So basically, it indicates the lower overlap of the observation and the prediction, because the trajectory fish is sometimes complex. So it is high overlapping. It's like wrong detection. So we have to give the more flexibility of the intersection of our union value. For this way, I used ZIOU. Let's see the result, how it is improved. So the upper diagram is the default setting, as already we see this result, and bottom was the improved result based on this parameter setting. So, and it is, we can say it is greatly improved. And in case of OC short, it's just lost two identity 2 times. So let's visualize the video after the parameter tuning, both for short and OC short. Yeah, and we can see in many cases it's able to recover in both cases, but OC short is performed better here. And this is the statistical difference between short and OC short, the average result. So we can say the average identity loss was around 6 for the short, and it was around 2 for the OC short. In conclusion, you can say the OC short performed better as it is just lost 2 times, identity lost 2 times. And what make this difference is, I think, the momentum and recovery part that is called OCM and OCR of the OC short algorithm make difference from the short. And but still there are few cases that OC short failed to recovery. Basically, it was very complex trajectory and very long time of the crossing. And what is the important parameters for the parameter tuning? I can say this is the IOU, instead of using IOU, and we may optimize and increase the backspace. Yeah, that really helps. And you have to also consider the detection part. Is better the detector, that means better the performance. And in future, I'd like to do the include more parameter for the performance evaluation, like using MOTA, multiple object tracking accuracy, that is called ClearMod. And I also need to improve the video quality, like using high resolution camera and lighting and more closer view of the fish, and other ways of improving the algorithms. That's all my presentation. Thank you very much.